So let's see how it works. Let's go through a demo. And what I'd love to do is show you some of the capabilities that TSE offers. We'll just scratch the surface of the capabilities. Let me jump into this cluster. So what I'm accessing now is the TSE Management Console. This is a component that you would install and you operate within your production environment. It's not a SaaS-based service. And the Management Console is the point of interaction for the UI, for the APIs, and indirectly for the GitOps operations. The Management Console then observes and manages service mesh instances running on each of your production clusters. In this case, we have 2 production clusters that we onboarded, that we're synchronizing with and pushing configuration out to. It's extremely easy to get started with. Once you've installed the Management Console, you can then step through the Getting Started wizard and onboard individual clusters. So we can pop in a 3rd cluster, create that, and it'll provide you with the exact configuration that you need in order to onboard that cluster into TSE. Once onboarded, you can then deploy applications to the cluster using your standard interfaces, the standard tooling. There's no specific TSE operations required. Set up workspaces and configurations so you can then manage these resources from TSE, expose it through an Ingress Gateway, and send traffic to the application. So these steps make it very easy to get started and see the capabilities of TSE. Or you can go through the documentation, a work in progress, but again, goal-based, designed to help you understand how to install the management plane, onboard clusters, and work through your configuration. So having onboarded a cluster, let's just remove the one that we did as part of the test. We can then look at the capabilities that TSE offers. I mentioned that TSE provides a secure environment by default for the applications and services deployed into your cluster. Mutual TLS is in place with a common certificate authority across all of your certificates, all of your clusters, automatically managed by TSE, so that services can mutually authenticate themselves from clients to application, and you can apply sophisticated security policies to control who is able to access what, building up from a deny-all beginning to create just a proper zero trust environment for your applications. Having created the basic service connectivity, defining where necessary the operations to connect different clusters and perform failover, we can then look at what it takes to deploy and monitor applications. Applications are deployed as standard and will appear within the Tetrate Service Registry. Here, as we push traffic through, you can see the services that we've deployed, which are scattered across the different clusters. So we can see, if necessary, delving into an individual cluster to see the services that have been deployed there. When an application is deployed, it can then be exposed through an Ingress Gateway, and where necessary, TSE can automatically configure not just the Ingress Gateway, but also the Edge load balancer, an ELB or an NLB instance, and provision DNS entries so that your application is easily discoverable by external clients. By synchronizing automatically your application state and configuration with your Route 53 DNS, that then reduces the operational cost of deploying and managing application deployments. So through our Route 53 configuration, we can then look at the various zones that we're managing through TSE and the services and applications that have been deployed, or rather the DNS entries that have been deployed as a result of services being deployed within the TSE managed infrastructure. We can then look at what is running and configure additional capabilities for the applications. Here, if we look at the topology of the applications that are running, I have two clusters, as you may have noticed. I have, let's scale that down so we can see. I have in my first cluster, cluster 1, an Ingress Gateway managing traffic coming in to my book info application. And in my book info application, I've duplicated one of the services, the details microservice, and I'm running a second instance in cluster 2. TSE detects this, and it automatically creates the appropriate Istio configuration and manages this configuration in order to load balance traffic across both working instances of that microservice. TSE then further monitors the availability of those services, and should one of those services fail, so for example, the local details instance were to go down, TSE will automatically update the routing policies in each of the clusters to ensure that traffic is then routed to the details instance running in the remote cluster. Without any end user interaction, this provides a high degree of failover and security for internal services. It's not necessary to expose services through Ingress gateways, give them publicly routable addresses in order to route traffic from one service to another and perform failover. TSE does this with internal east-west gateway channels. And furthermore, services running in other clusters can discover and consume services in the first cluster. Here we have a sleep client running in cluster 2, which wishes to use the product page service in the book info application. Without having to make any configuration changes to the sleep client, TSE is able to set up an east-west gateway, the instance hidden here, in order to tunnel traffic from cluster 2 into cluster 1 to address that product page service. So you can very easily scale an application across multiple clusters, and you can deploy services, clients in remote clusters that consume the application exactly as if that application was running locally. With a unified service database, an service registry, and automatic service discovery, you can scale your application seamlessly across multiple different clusters. And all of this traffic and all of these relations can be fine-tuned and configured using the service policies that TSE implement. Identity can be transferred from one cluster to another. Service policies can be created to, in a very fine-grained fashion, control who is able to consume which target services. So with cross-cluster communication out of the box, with internal service failover out of the box, you'd think it becomes a challenge to understand what is happening in our compound application. TSE also addresses that. We can look at the observability capabilities. So let's having looked at the topology, let's start with our Ingress Gateway. We can get full logs and metrics over what's happening. We can jump straight into the service for that. So if we grab that, providing data on the true performance of each individual service, pulling out the individual sidecar latencies so you can see the impact that the sidecar has on the performance of a service, and delve in looking at dependencies. So where is that service receiving traffic from and sending it to? What are the detailed metrics that that service can expose on a per instance basis if necessary? But one of the capabilities that I find most useful when I'm running TSE is the ability to trace. Let's jump to there and find our service here and look at a trace for that service. So if I capture a trace, let's grab this one that happened 13 minutes ago. TSE automatically creates and manages tracing information in a lightweight fashion, not grabbing, instrumenting every single request, but grabbing sampling a small number of requests and accumulating traces over time. so you can understand the call graph that your application is taking. So looking at the Ingress Gateway and its total duration of 47 and a bit milliseconds, you can then drill down and look at the services that it called, look at the services that it then invoked, where those services were located. So in this case, we consumed the detail service running on cluster 1, but in other traces, you'll find that running on cluster 2, and get full metrics and timing for these services. So with this collection of capabilities, TSE provides you with the ability to build a platform that meets the needs of your application team, that provides an excellent developer experience, but leaves you with the ability to control and set the guardrails as to what can be deployed into your platform, who can talk to what are the security policies, the failover policies, the cross-cluster traffic policies that you have, and observe and fine-tune the performance so you can get the best out of your investment into EKS, Kubernetes, and TSE.